Okay, finally, let's have fun with our model. We train the model using a practically working trainer, which as discussed for the practical, as a difference between the practical model and the theoretical model. A practical trainer includes some of the techniques that makes the training more stable and sometimes may convert faster. So here is two big chunks of code, including how to configure the, the optimizer, which is to take the computed gradient of the model and apply that to the model with. You can have different schedules or plans for this kind of operation. Okay, we define this kind of optimizer. You can just use the code and it takes the model and takes the optimizer configuration, as well as do some adjust some setting up of the options, such as at what rate I will change the parameter, and at what rate I will change the rate I change the parameter, so on and so forth. Okay, so this is another topic. We don't get into the details in this lecture. So the bottom line is you give a model to that and you give the trainer configuration, it will return you an optimizer. And this is the main loop of the training. It takes the model, takes the data set. Sometimes you can include a test data set, but in this case, we only need the training data set and the trainer configuration, and it will build the function of perform the training, which is actually the logic is very, although it's a big fat function, but the logic is super simple. We just need to loop through the data set for several times. This several times is configured, okay, and then each time we train the model, okay, in a so-called epoch, and adjust the parameters, adjust the settings of the trainer, and report when necessary. Sometimes just print a nice looking progress bar, so on and so forth. And we also, this function is also be responsible, this object is responsible to maintain the checkpoints, so on and so forth. So there's it looks complicated, but there is no difficulty in understanding those code. This is a trainer. Okay, what we'll do is I follow an example online. I don't have the link here. The link will be in the reference of the web materials. And we follow that example. We take well, not tiny, basically a pretty respectable size of the work by Shakespeare and put them into a pure text file. Okay, and we use this large big chunk of text for training. We are train a decoder that mimics how Shakespeare wrote stuff. So let's do this. Okay, and we build a model. Okay, so I create a training configuration, and I do a trainer using the model training set and the training configuration, and then we just use one liner of train. I need to remind you that this one liner of code takes hours and hours and hours to run. This is very slow. I have already trained a model using another machine that has graphic processing unit for accelerator of those computations. Now I have the model trained and saved. I have saved checkpoints, which is I haven't take all the time to train the model for many times. I just let the model go through all the works. These works I collected for Shakespeare for one round. It is a lot of data, considering that we take 128 characters per sample and do this through the entire collection, not the entire, but the large collection of Shakespeare's work. Okay, have trained that, I load the data and treat it as a dictionary and kind of organization of the model parameters, and I use the model. I let the model to load those parameters. It does not change the structure of the model. It just use trained parameters to replace these randomly initialized model parameters. Okay, now let's see how that model works. Okay, one, let's do a to learn or not to learn. I convert each character of this into a tensor, into an integer, and convert that integer to a tensor. Notice this non ... means I need a singular, which is useless, but just a placeholder dimension in front. That means I have a batch, but this batch only contains one document. Here are some settings of the sampler. I set 128 characters. From that, you can take long, but I don't like to wait for too long because this computation is very expensive. Temperature is the default setting of 1.0, and we do randomly sampling. I like to see each time it generates different samples, and we take from the first 10 possibilities. Okay, after it's been done, we will have a sequence of integers, and then we will convert the integer back to characters, and we print out the string we have. Let's see what we have. Go. Oh, to learn or not to learn me? Somebody? Why? This is like you. Okay. Does reads like Shakespeare again, maybe, to show you that it's not just a random fixed thing. It actually writes things. To learn, not to learn. That it speaks me what? Okay, that looks funny, but probably because for some reason it does definitely looks like some English and Shakespeare's English. It's not like a random generated character sequence. Okay, and it is random. Okay, but if we train the model for more, it can learn better. And if we train a larger model for larger corpus, we will have a very, very powerful model. So maybe another trial. Okay, how we see like Australian does. Good day. Humor. Okay, good. So that's it. Have fun.